students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as application of integration. Let's see this. The first part in application of integration is how do you find the area of a region. Okay. For example, if they give you find area of a region bounded by the curve y is equal to x square plus 3 bounded by the curve y is equal to x square plus 3, the x axis and the line x is equal to 0 and x is equal to 3, right? I have to find out the area of a curve, right? Formula, one simple straightforward formula, required area. Area of any curved figure is nothing but it is the integral of its y coordinate, integral of y with respect to x. Now since I want to find out the area, I should know the lower limit and the upper limit. From where to where? From x is equal to 0 to x is equal to 3. X is equal to 0 to x is equal to 3. That's how you find out the area of a curved figure. Now, they've already given you that 0 to 3, the value of y is nothing but x square plus 3 with respect to x. This can be written as integral of 0 to 3 x square with respect to x plus 3 0 to 3 dx. Integral of x square is nothing but x cubed by 3 from 0 to 3. Integral of dx is nothing but x from 0 to 3. This is 1 upon 3, 27 minus 0, upper limit minus lower limit, minus 3, 3 minus 0, upper limit minus lower limit. This is 9 plus 9, so that is 18 square units, right? That's how you get the area of a curved figure. Now let's try to find out the area of various figures. Find the area of the circle. Find the area of the circle. X square plus y square is equal to a square. Now if the area of the circle is x square plus y square is equal to a square, that means it has to be a circle that is passing through the center with origin 0, 0 and radius equal to a. If the equation of the circle is given to you as x square is equal to a square, that means it has to be a circle that is passing through origin 0, 0 and has radius a. That means this radius is going to be, this point is going to be a, 0 and this point B is going to be 0, a, right? Now, first let us try to find out the area of this region, right? Let us look at this region. This region starts from origin and on the x-axis it is ending at x is equal to a, right? Now, I can say that area of circle is nothing but x square plus y square is equal to a square. Therefore I can say y square is equal to a square minus x square. Y is root of a square minus x square, right? Now let's try to find out area of shaded portion. Area of shaded portion in the first quadrant, integral of, from where is this area starting? From x is equal to 0. Where is it ending? At x is equal to a. So it is starting from 0, it is ending at a. I told you that the formula for area is y dx. So this is going to be 0 to a, integral of y. Y is nothing but square root of a square minus x square with respect to x, right? Now, in this case, this is nothing but, now, integral of root of a square minus x square. is nothing but x by 2 root of a square minus x square minus plus a square by 2 sine inverse of x by a when the limits are between 0 to a. Now, let's see this. First you substitute x with upper limit, then you substitute it with lower limit. So this is going to be a by 2 root of a square minus a square plus a square by 2 sine inverse of a by a. I'm substituting with upper limit minus lower limit. 0 by 2 root of a square minus 0 plus a square by 2 sine inverse of 0 by a. I'm substituting x with upper limit, then I'm substituting it with lower limit. Sure. See, you got till here, right? This is the formula. Integral of root of x, a square minus x square is nothing but x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. That's the formula of indefinite integrals. Okay. Once you have this, then substitute the value of x first with upper limit. This is just plain application of formula. This is going to be a by 2 root of a square minus a square plus a square by 2 sine inverse of a by a. I'm substituting x as upper limit minus lower limit. So 0 by 2 root of a square minus 0 plus a square by 2 sine inverse of 0 by a. Now, this can be written as a square minus a square. 0, root of 0 is 0. Anything multiplied by 0 is 0. This is nothing but a square by 2 sine inverse of a by a. That is 1 minus anything multiplied by 0 is 0 plus a square by 2 sine inverse of 0. Now, this is going to be minus that much. This is okay. Now, this can be written as a square by 2 sine inverse of 1. We know that sine 90 is 1. So, sine inverse of 1 is going to be nothing but 90, which can be written as pi by 2 minus a square by 2 sine inverse of 0 is 0. So, this is going to be a square by 2 into pi by 2. So, this is going to be pi a square by 4. That is the area of the shaded region in the first quadrant. But what is the circle made up of? The circle is made up of such 4 quadrants. Therefore, what will be the area of the circle? The area of the circle will be nothing but 4 times area of shaded portion. So that's going to be 4 into area of shaded portion. Area of shaded portion is, we just found out as pi a square by 4. That's pi a square. So area of the circle is going to be pi a square.
So in that step, in the under root a square minus a square, 1 more.
Okay.
So that becomes 0. So then the only term remaining in the next
is
step
a square by 2 plus sine inverse of a by a, which is nothing but 1. This whole term becomes 0. A square by 2 as it is. Sine inverse of this is going to be a by a, which is 1.
So what's the second?
Minus, then this is 0. Anything multiplied by 0 is 0.
I got it.
Right? Next, take on next one please. Find area of ellipse whose equation is x square by 25 plus y square by 16 is 1. Right? I can say therefore they give you equation of ellipse is nothing but x square by 25 plus y square by 16 is 1. Therefore I can say that a square is 25, hence a is equal to 5 b square is 16, therefore b is equal to 4. Right? Once I have the value of a and b, let's draw the figure, guys. This is my origin. This is going to be my point A, 5, 0. This is going to be my point 0, 4. Right? Let's first find out the area of this shaded portion in the first quadrant. Right? I can say that before I find it out, equation of ellipse is given by the formula x square by 25 plus y square by 16 is 1. Therefore, I can say y square by 16 is 1 minus x square by 25. In which case, I can say that y square by 16 is 25 minus x square upon 25. Right? Take 16 on the other side. So, in which case, you will get y square is 16 by 25. 25 minus x square. Right? Therefore, I can say y is 4 by 5 square root of 25 minus x square. Right? Once I have the value of y, I can say that area of shaded portion is nothing but integral of y with respect to x when the limits are from 0. Guys, the figure starts from x is equal to 0 and goes on up till x is equal to 5, from 0 to 5. Now, this is integral of 0 to 5, 4 by 5. I'm substituting the value of y, people. This is 25 minus x square with respect to x. Whatever is constant goes outside the integral, 0 to 5. Root of 5 square minus x square with respect to x. 25 can be written as 5 square. We already used this formula a square minus x square. So this is going to be 4 by 5 as it is. This is nothing but x by 2 upon root of a square minus x square plus a square by 2 sine inverse of x by 8. Right? I'm using the formula integral of square root of a square minus x square. Right? When the limits are between 0 to 5. Right? Now, leave the 4 by 5 as it is. 4 by 5 as it is. It is going to be upper limit minus lower limit. So this is going to be 5 by 2 root of 25 minus 25 plus 25 by 2 sine inverse of 5 by 5. That's upper limit minus lower limit. 0 by 2 root of 25 minus 0 plus 25 by 2 sine inverse of 0 by 5. Right? Once you have this, you could solve this and get the answer. This can be written as 4 by 5. This is 5 by 2 into square root of 0. Anything multiplied by 0 is 0 plus 25 by 2 sine inverse of 1. Sine inverse of 1 is nothing but, sine inverse of 1 is nothing but pi by 2 minus 0. Anything multiplied by 0 is 0. Right? Plus 25 by 2 into sine inverse of 0. Sine inverse of 0 is 0. Right? So in that case, you will have this as 4 by 5, 25 pi by 4. And do we get this in here? So in which case, you will get this as 4 and 4 1, 5 pi right? But this is the area of the shaded portion, and ellipse is made up of such 4 symmetrical shaded portion. Therefore, I can say that area of ellipse is going to be 4 times area of shaded portion. So this is going to be 4 into 5 pi. That's 20 pi squared units. Right? Next, let's see our next exercise. Find the area. Find area bounded by the parabola y square is equal to 4ax and lattice rectangle. Right? Let's try to first visualize the figure, people. Parabola, y-axis, x-axis, origin, lattice rectangle. Fine. They have said that find the area of the parabola y square is equal to 4ax. The equation of parabola is given to you as y square is equal to 4ax and lattice rectangle. That means I want to find out the area of this whole region. Right? For the timing, I'll take just the first quadrant. Now, we know that for a parabola, focus is a, 0. For a parabola, focus is nothing but a, 0. Now, I can say that equation of parabola is y square is equal to 4ax. Therefore, I can say y is equal to 2 square root of ax. Right? Now, once I have this, I can also say that focus S is a, 0 for a parabola. That means area of the shaded portion, is going to be nothing but integral of, it starts from 0 and it goes on up till a. So it starts from 0, goes on up till a. Y dx, integral of 0 to a. Y we know is nothing but 2 root of ax dx, which is nothing but 2 root of a integral of 0 to a root x dx. Root x can be written as x raised to 1 by 2. Root x can be written as x raised to 1 by 2. So this is 2 root a x raised to 1 by 2 plus 1 upon 1 by 2 plus 1 plus, when the limits are between 0 to a, I am using the formula integral of x raised to n is nothing but x raised to n plus 1 upon n plus 1. This is 2 root a x raised to 3 by 2 upon 3 by 2 when the limits are between 0 to a. This goes up here 4 by 3 root a x raised to 3 by 2 when the limits are between 0 to a. Upper limit minus lower limit. So 4 by 3 root a. This is a raised to 3 by 2 minus 0 raised to 3 by 2. Upper limit minus lower limit. So this is going to be 4 by 3 root a. Now root a can be written as a raised to 1 by 2 into a raised to 3 by 2. Laws of indices, a raised to m into a raised to n is nothing but a raised to m plus n. So this is 4 by 3 a raised to 4 by 2, which is nothing but a square. So this is going to be 4 by 3 a square, right? But what is the area of the region between parabola and lattice rectum? It is nothing but twice the area of the shaded portion. Symmetrical figure on both the coordinates, it's going to be same. So 2 into 4 by 3 a square, that's 8 by 3 a square. That's going to be my area of the region that is bounded between the parabola and latus rectum. Next. Let's find the area of the region. Area of region bounded by the curve y is equal to cos x from x is equal to 0 to x is equal to pi. Right? Right, let's try to see what kind of curve it's going to be. This is your x-axis, y-axis. Now it's a cos curve. Cos curve, when the angle is 0, your amplitude will be maximum. This is 0, pi by 2 and pi. So your curve is going to be something like this. This is how a cos curve looks like. Sine curve starts from 0, cos curve starts from maximum amplitude, right? That means I need to find out area of this region plus area of this region. Let's assume that area of this region is A1. Let's assume that area of this region is A2. Right? Let's try to see one at a time. So this is how my cos curve is going to be between 0 to pi. So this is your cos curve between 0 to pi. Now, let's first find out A1, area. Area is integral. Now for A1, it is starting from 0 and it is ending at pi by 2. It is starting from 0 and it is ending at pi by 2 y dx. Right? So this is going to be 0 to pi by 2 y. Y can be written as cos x dx. Integral of cos x is nothing but sin x when the limits are between 0 to pi by 2. Right? So this is going to be sin 90 minus sin 0. Sin 90 is 1. So answer is 1. So area of this region is going to be 1. Now let's try to find out the area of the second region, which is going to start, right, the second region starts from pi by 2 and ends at pi. The second region starts from pi by 2 and ends at pi. So in that case, it starts from pi by 2 and it ends at pi. It starts from pi by 2 and ends at pi. Y dx, y is nothing but pi by 2 to pi. Y is cos x dx. This is integral of cos x is nothing but sin x when the limits are between pi by 2 to pi. Right? Now, this is going to be sin pi minus sin pi by 2. Right? This is nothing but sin 180, which is 0, sin 90, which is 1, which is minus 1. But can area ever be negative? No, area can never be negative. Therefore, I can say that the modulus of area is nothing but 1. Therefore, what is the total area? Total area bounded by the curve is nothing but A1 plus A2, that's 1 plus 1, that's 2 square units. Right? Next, let's move on to another sum, guys.
So, yeah, so we could have doubled it.
No, because that's not symmetrical figure. It's not starting from 0. See, I could have doubled it had the figure been from here. Had it been this way. Had the starting point and end point been the same. I could have, in all these cases I've been doubling it because my starting point and my end point is the same. Here, why did I double it? I did not double it because my starting point and end point is not the same. My starting point is pi by 2 and my end point is pi. That's the reason why I didn't double this. Right? Do you understand this? And you will see that here you got a different area. Just a coincidence that the magnitude came out to be the same. Right? You have to make sure that your start point and end point is same if you are doubling the area. Right?
So because this becomes like a semicircle, right?
No. This part.
The area wise.
This semicircle, if it was from the same point, I'm finding out area of another point. So how will it be semicircle? Fine, do we get this thing clear? For it to be semicircle, it should have started from here. You don't have the same point. I'm cutting the circle and I'm taking it in a different plane. I'm cutting it. See this, suppose this is it. If I cut this and I twist this, it won't be a semicircle, right? Next, let's move on to the next one, guys. Find the area of the region. Find the area of the region. Find the area of the region common to the parabolas common to the parabolas 4y square is equal to 9x and 3x square is equal to 16y. Right? Now this should be an interesting sum. Let's see this. Y square is equal to 9x. That means the parabola is going to be like this. This is going to be my parabola. Right? This is my x-axis. This is my y-axis. X square is equal to 16y. That means my parabola has to be this way. This is going to be my parabola. Right? This parabola is 4y square is equal to 9x. This parabola is 3x square is 16y. Right? I have to find out area of this region. The region which is common to both the parabolas. The sum says that find the area of the region common to both the parabolas. Fine, do we get this thing clear? Now, since the two parabolas are intersecting at this point, let's call this point as say R. Right? Since the two parabolas are intersecting at point R, let us assume if they are intersecting, that means I should be able to substitute the equation of one in the other. If they are intersecting each other, if they have a common point, that means I should be able to substitute the equation of one parabola and another. I can say that 3x square is equal to 16y. So in which case I could say that y is 3x square upon 16. Right? Substitute this equation of y in the equation of other parabola. Since the two parabolas are intersecting, I should be able to substitute the equation of one in the other. I can say equation of other parabola. Equation of other parabola is going to be 3x square is equal to, no, we've already used that. The other parabola is 4y square is equal to 9x. 4. We found out the value of y as 3x square by 16. The whole square is equal to 9x. So in which case I will get 4, 9, x raised to 4. 16 into 16 is 9x. 9 and 9 gets cancelled. 4 1s are, 4 4s are. So in which case you will get x and this gets cancelled, cube. So you will get x cube is 16 into 4. X cube is 64. X is equal to 4. Right? Once I get the value of x, then I can find out the value of y. I can say that therefore y is nothing but 3x square by 16. So 3 into 16 by 16, so y is equal to 3. That means my point of intersection R is going to have coordinates 4, 3. Right? Once I know my point of intersection now, let's try to find out, take one parabola and let's try to find out the area. Let's first consider the parabola which is along x-axis. Let us first consider the parabola which is along x-axis. We know that the point of intersection R is 4, 3. Right? Let's try to find out the area of this whole region. Right? Let's try to find out the area of the region from here. Let's call this perpendicular as Q. Now, if RQ is perpendicular to x-axis, in that case I can say that Q is going to have coordinates 4, 0. If RQ is perpendicular to x-axis, then Q is going to have coordinates 4, 0. So I can say that area, you call this area as say A1. A1 is going to be integral of 0 to 4. It's starting from 0 and is going on up till 4, y dx. Now the equation of this parabola, was 4y square is equal to 9x. Therefore I can say y square is 9 by 4x, y is equal to 3 by 2 root x, right? Substitute the value, so in which case you will get A1 is integral of 0 to 4 y. Y can be written as 3 by 2 root x dx. So in that case this is going to be 3 by 2 when the limits are between 0 to 4 root x dx. 3 by 2 root x. Root x can be written as x raised to 1 by 2. So this is going to be x raised to 1 by 2 plus 1 upon 1 by 2 plus 1 when the limits are between 0 to 4. So this can be written as 3 by 2 x raised to 3 by 2 upon 3 by 2. 3 by 2 when the limits are between 0 to 4. 3 by 2 and 3 by 2 gets cancelled. So this is going to be x raised to 3 by 2 when the limits are between 0 to 4. Right? So this is going to be 4 raised to 3 by 2 minus 0 raised to 3 by 2. Now 4 cube is nothing but 64 under root. So this is going to be 8. So area of this region is going to be 8 square units. Now let us try to find out the area of the other parabola, right? Let's consider the other figure. We know that this point is R and the point of intersection R is 4, 3. Let's drop perpendicular Q here, right? So Q is going to be 4, 0 because it's perpendicular to x-axis. Let's try to find the area of this region, right? How do I find out the area of this region? I can say that, let's call this area as say A2. So I can say A2 is integral, it is starting from 0, it is going up till 4 y dx, but the equation of this parabola is 3x square is 16y. 3x square is 16y, in which case I can say y is 3 upon 16x square. Substitute the value of y, in which case you will get A2 is integral of 0 to 4 y. 3 by 16 x square dx. This is going to be 3 by 16 comes out, integral of 0 to 4 x square dx, which is nothing but 3 by 16 x cubed by 3. When the limits are between 0 to 4, 3 and 3 gets cancelled. This is nothing but 1 by 16 x cubed, that is 4 cube upper limit minus lower limit, 64 by 16, that is going to be 4. In that case, what is area of the shaded region? Area of the region between two parabolas is going to be nothing but A1 minus A2. Right, do we get this thing clear? So in that case, A1 you had found out as 8, A2 you found out as 4 square units. Right, so the area of the region between the two parabolas is going to be 4 square units. Right, this finishes the sum. We'll stop this here for the day. Thank you very much.